This video shows how the Integrated Decision Support Tool, the IDST, can be used to run a stress test under the overarching risk assessment methodology that is described in the InfraRisk project. In this particular example, we are going to perform a stress test based on the Italian road network case study. The initial page of the IDST software explains that it is an online tool to assess risks to critical infrastructure caused by extreme natural hazard. The About page under the Help menu provides you with more information and links to the InfraRisk project website. In order to use the IDST, the user has to log in. The IDST can use several authentication services such as Mozilla Persona, Google, Yahoo, and LinkedIn. In this example, we use our account from Mozilla Persona to log in. Upon successful authentication, the user can access the ISDS Dashboard, which allows users to create stress tests as well as to revisit previously run stress tests. The steps in the overarching risk assessment methodology developed in the InfraRisk project are provided in the overarching methodology process diagram. A more detailed description of each step can be found by accessing the tooltips associated with each step. From the dashboard, the user can either define their own stress test or use predefined stress test, for example, from the Italian road network case study. To start, select the example case study Italian road network and click on the Proceed button. A predefined stress test for the case study can then be started. The Define Stress Test page is already predefined for our example. However, the user can alter the name and summary fields. Once a summary has been entered, press the Save and Proceed button to continue. The first step is to define the system. The spatial boundaries define the extent of the network or area over which the stress test will be conducted. In this case, for the predefined stress test, the area around Bologna is selected. Multiple spatial boundaries can be added by pressing the button below. In this demonstration, a provision has been made to allow the user to manually create an additional set of spatial boundary, which we call a test boundary. Achieved by selecting an area around the Bologna region. As we can see, now there are two spatial boundaries of interest defined for our stress test. The next step is to define the hazard scenario. A hazard scenario is defined as a set of hazard source and a set of hazard events with their assigned models. For the predefined Italian case study, the hazard source is earthquake and the hazard events are ground motion and a triggered landslide hazard event. Subsequently, we must configure selected hazard models, in this case, the ground motion model. This hazard model for the ground motion has been developed within the InfraRisk project. The user is required to choose parameters for the seismic activity model, ground motion prediction model, hazard level, and the fractile of extreme ground motion at a particular point. Information on these parameters can be found in the help section and the relevant tooltips of the form. Having set up the hazard models, the next step is to configure the network scenario. For this step, the user must define the network characteristics such as the network infrastructure, for example, road network or rail network, and the network element types such as bridges, tunnels, and road sections. For the elements types, hazard events should be assigned, as well as models that assign fragility functions to element types. In addition, the spatial boundary to the network should be assigned. For the Italian case study, the selected network is the road network. We must also select the element type. In this case, we have a bridge type which has an assigned ground motion hazard event. The fragility model defined is the model presented in WP on single risk assessment of the InfraRisk project. A similar process can be used for tunnels. Road sections can also be added. However, by default, they are not included in the predefined stress test, as the size of road section is large and computationally intensive for the purpose of this demonstration of the tool. These sections can be added manually by pressing the Add Element Types button. The last step involves assigning the spatial boundaries, for example, Northern Italy. Having defined the network scenario, the next step is to define and upload network element characteristics for the network element types. In other words, we need to add the real element data, such as for bridges and tunnels in this case. For this predefined stress test, we are using network element characteristics that have already been loaded into the ISDS databases. Having defined the datasets, the next step is to assign fragility functions. The network element overview shows graphically how many elements are found within the spatial boundary. By clicking on an element, the particular fragility functions being used can be viewed. The next step for this scenario is to select a critical element location and anchor the selected ground motion field at that location. What can be seen on the map. In the next page, the PGA grid is displayed as a heat map. At this point, we can calculate the damage state of each network element type characteristics, actual bridges and tunnels. The results of the analysis can be viewed on the network element damage state calculation page. The distribution of damage state among the elements can be viewed graphically in the network statistics section, and equally, the network damage state can be downloaded for further processing along with direct consequences estimations. Finally, the stress test report provides a summary page of the stress test performed and allows the user to download data such as the PGA grid and the damage state of the network elements used in a CSV format. This can be used for further processing of the indirect consequences using other analytics tools.